Hi, class. If you were absent May 20th on Thursday, we did this experiment in class, dry ice and acid-base experiments. You should open this up on Google Classroom, and I'm going to go through the 4 parts of the experiment with you. You can watch this video and then fill in the worksheet. I only have dry ice for today, so it's going to be all gone tomorrow, so I'm recording this now. All right, so we're going to start with part 1. It's just an observation of dry ice. Number 1 says, what chemical is dry ice? If you don't know, look it up, but it's solid carbon dioxide. And I'm going to get some dry ice for you to look at. Okay, so here it is. Hold it up. You can see it's solid, and there are vapors coming down. And the vapor is cool. That's carbon dioxide gas. And the kind of the cloudiness that you see is because water vapor in the air is condensing on the cool carbon dioxide. This is very cold. I would never touch it with my hands. This is minus 78 degrees Celsius. It would cause frostbite if I held on to it too long. Even a few seconds can damage the first layer of your skin. All right, so if I put this into a cup, okay, if I grab a few pieces, but even with one piece, you can see that the vapor flows downwards. And you can see this if I put some more carbon dioxide in here. Okay, more dry ice in here. So if I pour, okay, I think you can see that the vapor is what direction the vapor is going in. Let me hold it up here. Okay, and then you can answer the questions number 5, 6, and then for 7, I'll take a piece of dry ice and I will try to cut it with a utensil. Let me aim my camera down here so you can see it. So here's a piece of dry ice, and I can take my knife here. I'm going to warm it up a bit with my hands. Okay, and then I'm going to place this on here and see what you observe. It's screaming, does not want to be suppressed. Okay, so again, I'm going to warm up the knife with my hand, and I'll okay, so there's kind of a squeaky sound coming from the dry ice. And speeds up. If I do it this way, there isn't as much sound. It's kind of a sizzling sound. If I do it this way, especially if I warm this up, I can cause a more rapid sublimation in a sound. All right, so that's the end of part 1. We'll go on to part 2 now. All right, so this is part 2 now. Okay, so I've got a cup. It says a beaker. This is number 1, obtain a beaker halfway filled. I've just got a cup here with water. So I'm going to add some dry ice into it. See whether it sinks or floats. Okay, so let me put in a couple pieces, and you can see, oh, maybe you can't see, but the dry ice is not floating. It is staying down at the bottom here. Okay. So unlike water ice, okay, regular ice made from H2O, right, dry ice stays on the bottom. Okay, now I'm going to add some soap to my bubbles here, and hopefully I don't make a huge mess. Okay, so let me add some soap here. Okay, let me grab a tray, just in case I do make a huge mess. All right, so as the dry ice bubbles, you can see the bubbles growing, falling over. Ooh. So think about what gas is inside of the bubbles, what's making those bubbles there. Fun. All right, so that's number 2 with the soap. It says number 3 says pour the water out of your dry ice cup. Okay, so I'm gonna actually just get a new cup here with more dry ice. Okay, so now we've got more dry ice, so we're on number 3 in part 2. I've just got some dry ice here, and I'm gonna add some hot water to the dry ice over here. So this is gonna be the hot water. Watch what happens when I put in hot water instead of cold. Wow, that's really sublimating a lot faster, isn't it? Ooh, I love this. So we can see a nice, this is how you get fog and theater productions and stuff. So, all right, so that is part 2, dry ice with water. You can see the difference between adding dry ice to cold water versus adding hot water to dry ice. Okay, now we're on part 3. Okay, so for part 3, we are going to measure pH 3 different ways, and we're going to measure the pH of distilled water, dry ice in water, vinegar, and ammonia. So we'll start off with distilled water, and we're going to first measure the pH using these pH strips. Okay, so I've got some distilled water here. Okay, so to test this, I just dip this in, okay, and take it out, and then I look at the color coding here, okay, and you can decide what pH that is. Okay, so that's distilled water. Okay, the next one is dry ice in water. So there. Okay, so that's dry ice in water. Next, we have vinegar. And that's turning a reddish color. Okay, and then finally we've got ammonia. That turned blue. Bluish green. All right. So that's the pH paper. The next part is testing a pH with a meter. Okay, so now we're going to test the same solutions with a pH meter, and I have the pH meter right here. That's showing the pH. Let's see if I can get that showing. Okay, and the actual meter looks like this. It's a probe, and right now it's in some solution. I can take that out. Okay, and so it's a probe like this, and we just put it into a solution. Before we do this, though, we have to each time rinse our pH probe with distilled water because we don't want the solution from before contaminating our sample. All right, so the first thing that we're going to test is the distilled water. I'll put the probe in there and then take a look at what pH. This distilled water is a little bit acidic. I think it's absorbed some carbon dioxide from the air. We did have a lot of dry ice around. And with any electrical device, right, the pH is going to fluctuate. It's going to change back and forth, but after about 30 seconds to a minute, most pH meters stabilize. Okay, so you can see here, can move it around a bit. Okay, so there's the pH meter again, and let me rinse off my pH probe here. Okay, my next solution is the dry ice and water, so I'm going to put that in here. Okay, let me move it so that you can see the pH meter there. It's right there. Okay, you can see the pH, and it looks like it's stabilized right around 5.42. Okay, next solution is the vinegar. So let's put the pH meter there. So vinegar. .83. Okay. And then our last solution, let me rinse this off. Our last solution is the ammonia. Over here. And that doesn't seem very accurate here. Let's see, maybe oh boy. I'm gonna add some more ammonia in here just to. Okay, 7.53. I think the ammonia probably lost some oomph over time. Probably some of the ammonia evaporated, and so it's not as basic as it should be. Earlier, we were getting a pH of about 10, so just keep that in mind. But you should record what you saw there. All right, so then the final thing to do is to look at what the solutions look like when we add universal indicator, and I've actually already added the universal indicator into these. So the distilled water, you can look at the color. This is for pH using universal indicator, and then in that column, there's a chart that has a link. You can look at the color and match it, match this color to the color you see on the chart, and then give the pH. So that's distilled water. This is the dry ice in H2O. Okay, so you can see the difference there. And then finally, we have the vinegar and the ammonia. Okay. And then based on that, you should be able to say whether these things are acidic, basic, or neutral. And then number 5, say what method you think is the most accurate way to measure the pH. Okay, so this is part 4, where this is a piece of goldenrod paper, and I'm going to draw on it with different solutions. Goldenrod paper is dyed this color with turmeric. All right, so the first solution is ammonia. So that's right here. So I can take my ammonia. Okay, I can draw face. You can see what color it's turning. My next solution is vinegar. Basically, nothing seems to happen when I draw with the vinegar. Next one is hydrochloric acid. Well, I guess we know whether this is an acid or not. Okay, so if I draw on this, again, the hydrochloric acid, there's no result. Maybe the paper gets a little bit yellow. And then finally, the last solution is NaOH. And you can see it's turning the same color as the ammonia. Okay, so now you should be able to answer number 2. And then number 3, I'm going to make a line with ammonia. And then I will draw over the line with vinegar. So take the ammonia, I'll draw some lines here. Okay, and then I'll take some vinegar, get a new Q-tip, and I will draw over these lines. And look at that, it's magically erasing. Or is it magic? It's not really magic. So I can get rid of all of the red. Okay, so think about why that's happening, why the color is disappearing, the red color. All right, so that's it. And if you have any questions about any of the lab questions, please email me or talk to me in class. All right, bye.